Hello everyone, today in this video we'll be discussing the fourth module of database management system, and in this module we'll be discussing normalization. Okay, what does normalization mean? Normalization means if you have a database here and if you have redundant data in that, we'll be making that more simpler. Okay, that is known as normalization. So for normalization there will be some techniques which we'll be discussing. Okay, and yeah, that's it about this module. We have normalization first, the theoretical part, and we have some algorithms. Okay, so if you like this video, hit the like button and don't forget to subscribe to my channel. Okay, and let's begin with the first topic, which is the introduction to normalization. Okay, so there are some guidelines for the normalization which we'll be discussing now, and after the discussion of this video we'll be moving on to the previous year questions, and we'll be discussing that as well. Okay, so let's move on to the introduction of normalization. It's a technique of organizing the data in the database, and it is to filter the unwanted data and the redundant data from the database. Okay, that's known as normalization. So for carrying out that, let's consider an example here: student department. In this relation, what you can see is student name, roll number, gender, department name, office phone number, and HOD. Okay, so it has a redundant storage of data and must change at several places. See, if this is the data here and it has many rows also here, okay, means every value is filled here. And if you have to change like department name, okay, if you have to change the department name for each student in the same department, if the department name changes, you have to change it many places, here also, here also, here also. So that is one disadvantage. And redundant storage of data is that department name is same, right? We are writing many times here. And also gender, it's male and female, so we'll be writing male female many times here. So that is a redundant data. How can we overcome the redundant data is that we'll be separating the tables into many parts. Also there are few guidelines. Okay, so the first guideline is that reduce the redundant data. Okay, for example, there are two tables like employee table and department table. Fine, so we'll have the redundant data here as many rows if it is changed. Okay, so don't join two tables, for example employee table and department table. If you join two tables, what will happen is we'll again get the same thing as I have discussed here, which is the redundant data and must update the department at many rows. Okay, if it is changed. So since in the if the tables are joined, we'll have department name many places, that should all be changed. That's the first guideline. Don't join two tables, instead make two tables. Means if you have the employee department table here, separate it and make it as employee table and department table. That's our first guideline. If you violate this guideline, what will happen? The first thing is insertion anomalies. What does that mean is, if there is a table employee department and there is no employee as of now, then only department should be added. What will happen is, if we only add the department in this table, suppose that we have just created a new office here and the departments are ready. Okay, so we have to add the department information in the database. Since the employee department table is integrated in one table, what we have to do is we have to leave the employee values as empty, since no employee is joined yet as of now, and we have to add the department values. So when we add just the department values, what will happen is these values will be null, and also there will be SSN, employee SSN, and all those are the primary values, and primary values cannot be null, right? So that is one constraint. That is the violation of one constraint, that is insertion anomalies. Okay, and deletion anomalies means if there is one employee working in one department, for example employee 1. Okay, employee 1 is working on chemistry department. Okay, and only employee 1 is working in the chemistry department, and if employee 1 leaves, what we should do is we have to delete this row. When we delete this row, the department value will also be deleted, so we'll lose the information of the entire department, right? So that's one another disadvantage of joining the tables. Okay, which is the deletion anomalies. Then finally we have the modification anomalies. What is the thing is that if we miss some of the database becomes inconsistent. Means if while updating manually, what will happen is, if you miss any of the values in between, it will be inconsistent database. So that's also one of the disadvantage of the joining two tables. That was all about the guideline 1 and what are its violations. Okay, guideline 2 states that the consistent and has no insertion, deletion, and modification anomaly should be there, and the statements are to be executed when what statements are to be executed when the violations happen. Okay, so suppose that if there are null values in the tuple, and it's a waste of space, because if many of the values are null, it means suppose that, see here, if like 80% of the values are null, only a few values of one column are field, or why it is null is because it doesn't apply. For example, student name is here and the office phone number is here. Some students work part time, so they have office also and their phone number will be written here, but rest of the students don't have phone number, there will be null. So what are the disadvantages? That wastage of space in storage, and may lead to problems with understanding the meaning of attributes. Since many are null, it will be hard to actually know what is the meaning of that attribute. And count sum function will be giving the wrong result because many of them are null, so that will be not considered in sum and all, and the join operation become complex. Okay. And the third guideline is that make null values in the tuples as exceptions if there are very few of them. If there are very few of them, like only 2 or 3 have from among like 10 to 20, at that time we can make it as exception. Okay. So what does exception mean? Means in that particular row only the value is there. Okay. What is the general rule? General rule is there is no value in that column and it's empty. That is a general rule. Wherever the exception is there, we will be marking it. Okay, that is the third guideline. If we violate the third guideline, what will happen is we will be this spurious tuple will be formed. Okay, spurious tuples are those tuples which are generated when two tables are joined. Okay, it is not actually present inside the table, but it gets created as a result of mixing the two tables. Okay, that is the spurious rows. And for example, if we have the two like employee and locations and employee and project, we can separate this into employee and location separately, employee and project separately. Okay, instead of having both in a single table, we can have two separate tables. Okay. The fourth guideline is a pretty simple one because it says like design the relation schemas that they can be joined with equality conditions on the attributes that are appropriately related. Means whichever two tables you are considering, they should have the same type of primary key and the foreign key. Okay, then the relation of the relationship schema can be easily designed. Okay, let's discuss about functional dependencies. What does functional dependency mean? In functional dependency, a value x is dependent on y. Okay, for example, see here in the employee project, what we have is SSN is dependent upon e name, means we will make a arrow like this, and p number is dependent on p name and p location. So p number will have two things here, p name and p location, and last one SSN and p number is dependent on ours. Okay, means both of these are totally dependent on ours. Okay, so if I make in the separate figure, we'll have these things. Okay, this is the diagrammatic representation. SSN and p numbers both on R, and e name on SSN, and p name on p number. Okay, these are the three functional dependencies. Okay, now what is the thing which we have to keep in mind? The functional dependencies specify that the value of an employee of social security number SSN is uniquely determines the employee name e name. Okay, since SSN is just dependent on e name, we can get the e name by unique SSN. Okay, that's what it says. And p number can determine p name and p location. If I give you p number, you can easily tell me what is the p name and p location, because these two values are dependent on p number. Last one, SSN and p number, if I give you, you can tell me what is the number of hours working. Okay, so that is the thing which is being specified here in the functional dependency. And what we need to keep in mind is the normal forms. Okay, whenever we will be performing three tests here, which is based on the database to be normalized. Okay, before that, let's revise what is the candidate key. Suppose that there are many keys here which can be formed as primary key, for example SSN or name or roll number. There are many attributes. Okay, you can choose any of them to be a primary key, and the remaining one will be candidate key. Secondary key is the secondary key is the key which is left after the selection of primary key. If A, B and C are the candidate key, A is selected as primary key, then B and C are secondary key. Okay, these three are candidate key. If A is primary key, B and C will be secondary key, and since A, B, C are candidate key, it's also known as prime attribute, and which are remaining except the prime attribute are non-prime attribute. Okay. In the normalization procedure, there are a total of 5 normal forms. So let's discuss each normal form one by one. Okay, so the first normal form is that the attribute should be atomic. Okay, it should not be divisible. What do I mean by that is, for example, if you consider department here, in department we have D name, D number, and manager SSN and D location. If you see D location, we can specify D location in multiple values, right? So that should not be the case. There should be only one value. So it violates the first normal form. In first normal form, all the attributes which are present here should have one value. Okay, it should not be divisible. Since it has multiple values in D location, it can be divisible here, right? So how can we do this one? So to solve this, we will be removing the attribute D locations that violates one NF and place it in a separate relation. Okay, so how do we do that is, so here D number to D location is a distinct tuple in department locations. So when we decompose it, we'll be having two 1F relations instead of one non 1F relation. Okay, so what do we have is, we'll be separating this one and we'll be having one table this one and another table D name with each D location once. Okay, means if D name is like A and B and C here, A with the first location here, A with the second location, A with the third location, like that we will have B with the first location, C with the first location, like that we will have in a separate table. Okay, that is how we achieve the first normal form. Okay, and the second normal form is based on the concept of full dependency. Now suppose that this is the table which we have employee project. Okay, and SSN and P number are dependent on ours, and E name is dependent on SSN, P name and P location are dependent upon P number. Okay, so in the above figure, SSN and P number ours is a full dependency, because which are the prime attributes here? Prime attribute means which is the primary keys, SSN and P number. The remaining are the non-primary keys. So what is our main aim is that each of these non-primary key attributes should be dependent on SSN and prime number. Both it should be dependent. Okay, means all the primary keys it should be dependent. So ours is dependent on both. But what about E name? What about P name? What about P location? They are not dependent totally on both of these, because E name is just dependent upon SSN and P name and P location are just dependent upon P number. So here is a partial dependency. In second normal form, every non attribute, every non prime attribute should have full dependency. Okay, so we'll be separating them into different tables, because only FD1 is the full dependency, FD2 and FD3 are not full dependency. So what we do is, we'll be separating them into different relations such that we'll have like this. Okay, since SSN and E name only there is dependency, we can't have P number also in the same table. So therefore we'll be making a separate table for this one. Same thing goes for P name and P location. Okay, in P name and P location it dependent upon P number only. So we'll be having P number here along with the other two attributes. So totally we'll have three tables instead of one table, and which satisfies the second normal form. These all satisfy the second normal form. Okay, after that we have the third normal form. Okay, so here the transitive relations are checked. What do I mean by transitive relation? A to B and B to C. Then I can directly write A to C, right? That is a transitive relation. If you observe here carefully, I have a relation from SSN to D number, and from D number I have to D name and D manager SSN. So here is a transitive relation, right? So we can normalize it by decomposing it to 2-3NF relation schemes. Okay, one will be for this much only and another will be this much only. So we'll have two tables here instead of one. First will be for till D number and the second will be from D number here. Okay, there should be no transitive relation, then it will be 3NF validated. Okay, so that is for the 3NF, and inside that we have a subtopic which is Boyce code normal form. Here it is the next version of 3NF, means an updated version of 3NF. Here if there is any non-prime attribute that determines a prime attribute, BCNF's constraint is violated. What do I mean by that is, suppose SID is here and major is here. These are the prime attributes. Okay, if any of the non-prime attribute is determining the prime attribute, then that will be the violation. How can I say if any non-prime attribute is determining the prime attribute? See here, faculty 1 is here. faculty 1 teaches physics. Also here also faculty 1 is there. Faculty 1 teaches physics. Okay, so how do I know what does faculty 1 teach? So faculty 1 is just dependent upon one of the prime attribute, not both of these. So this is determining the prime attribute. That should not happen. So for that, what we will do is we'll separate these two into a separate table, and we'll separate these two into a separate table. Okay, so after doing that, what we'll obtain is these two. Okay, SID determines the advisor, means who is the advisor for each of the student ID, and what each advisor takes. In this, advisor will be the prime attribute. When we have these two tables, it doesn't violate the BCNF condition. Okay, so just make sure that you don't have like non-prime attribute to prime attribute relation. Okay, the fourth normal form is the multi-valued dependency. Suppose that there is a employee relation here. There is a person called Smith, and there is a project X and Y. Two projects are there, X and Y, and the employee name is Smith. And for each project there is a dependent name. Okay, means for project X it is John, project Y it is Anna. Okay, so if Smith is working on project X, the dependent name is John. If Smith is working on project Y, the dependent name is Anna. Okay, if Smith is working on project X, the dependent name is Anna, and Smith is working on project Y, the dependent name is John. So there can be four possibilities. Instead of having redundant data, because X is repeated twice here, John and Anna is also repeated twice, Smith is repeated 4 times, what we can have is a small two tables we can have. In two tables, firstly we'll have this one. Smith is working on two projects, which is X and Y. Also, Smith has dependencies John and Anna. Okay, if you have like this in this form, if you have the relation, that is the fourth normal form. Okay, and lastly we have the fifth normal form, which is the joint dependencies. Okay, if you observe here carefully, some things are repeated here. We are just removing the redundancies. That's the main aim of normal form, right? So in fifth normal form, what we have is, if you see here, Smith and Bolt, this is repeated again here, Smith and Bolt. If you see again here, Adam Sky Bolt, Adam Sky Bolt, it's getting repeated, right? So instead of writing this multiple times, we can just have a single table in which it is written once. Okay, also you can see another similarity here, Bolt and project X. Where is another Bolt and project X? Here, right? So this is the redundant data. We can remove that. How can we do that? We'll have three tables here. First for S name and part name and project name, S name and project name. Three tables will be there. Fine. So if we write these tables in this form, there will be no redundant data. Every row in these tables are unique. Okay. By using these three tables, we can again form the original table. Okay, but here it is taking less space, and there is no redundant data. Okay, that is the main aim of fifth normal form. Okay, so that was all about the theoretical topics of the normalization. The next one, we have the algorithms. Okay, so there are some inference rules for the algorithms, and the first rule is the reflexive rule. Okay, in this rule, what we have is, it states that a set of attributes always determines itself or any of its subsets. Okay, so what does determining mean? If there is a set here and there is a subset here, all of these whatever attributes are present here, that is obviously present here also. So all of these attributes are determined by the main function, right? So that is the first rule, reflexive rule. Okay, second is that if you have the relation in this type, x tends to y, then adding z to both sides will not make any difference, right? Xz determines yz. Okay, the third one is the transitive rule. If x determines y and y determines z, then x will determine z. Okay, and the fourth one is, if x determines yz, then obviously x will determine y also x will determine z. Okay, and x determines y, x determines z, therefore x determines yz. Just combine y and z here. Okay, and x tends to y, and wy tends to z. That means we can replace wherever y is present here with x. So it will be wx determines z. Okay. So based on these rules, we have an algorithm here. Let's understand the working of the algorithm. Okay. Suppose that we have f which is equal to assistant determines e name, p number determines p name and p location. So firstly, in this algorithm, what we have is a set of f on of fds on a relation schema R, and a set of attributes x which is a subset of R. Okay. R is a subset which R is a set which have all these things, SSN, e name and all, and x is a subset of it. Okay. So x is each of these. Here is one x, another x and another x. Okay. So what we have to do is we have to choose the first x here as the initial x, and what we'll be doing is we'll be considering the previous x also. Okay. And we'll be filling it by the subsets. So how do we do that is, first what we'll do is, see here, SSN can you find here anywhere? No. Can you find ename anywhere, p number anywhere here? No. So SSN and p number are separate entities. It doesn't have anything in common. So let's move to the third one, which is SSN and p number. Here we have both of these, right? So suppose that if I substitute instead of p number, p name and p location. So what I will have is p name and p location will be present here, and instead of SSN I will have e name also here. So how many entities I have here? E name, p location instead of these two, and R's. Okay. So that's what I will write here: e name, p location and R's. Okay. But since we have to use the algorithm to write SSN and p number also, so we will be writing here initially SSN and p number. So that's it. What we are doing is we are just substituting the previous values from the given x values into the new x value. Okay. Then whatever set we have, that's the final answer. Okay. So equivalence means that if there are two sets here, they are functionally dependent upon each other if they are equal. Okay. For example, if we have to find out the minimal cover using this algorithm. Okay. So there are three things given to us: b tends to a, d tends to a, and ab tends to d. So what are the changes which we can make? The first step is to check if there is you have to break down the RHS for each functional dependency into a single attribute. Here all RHS are single attributes. Okay. Means in RHS, can you find any two attributes or something like b tends to a, one attribute, d tends to a, one attribute, ab tends to d, one attribute. Just check the RHS. Then we'll check the LHS also. Check if AB tends to D has any redundant attribute on the left hand side, that is it can be replaced by B tends to D or A tends to D. See here AB tends to D is there, right? Can this be replaced by B tends to D only or A tends to D only like the other two? We will check that. Okay. So if it is B tends to D, that's the more probable one because we have B in the LHS part. So what we will do is we will write AB tends to D, and after that we will be choosing the first one here, B tends to A. Okay. So if B tends to A, see here, if B tends to A and I multiply both sides by B, that will not make any difference. So it will be BB tends to AB, right? See here, what I had is B tends to A. This is what I had. I multiplied B by both sides. So what I will have, BB tends to AB. So I will write a BB tends to AB. Since BB is equal to B only, I will be writing B tends to AB. Now I got this relation, B tends to AB, but already I have AB tends to D, right? So I can remove AB, I can just consider B tends to D, that I will be writing here. Okay, B tends to D. Now if you observe here, B tends to D I have, D tends to D, D tends to A I have. So I can directly write B tends to A, right? Transitive relation. So this one is already derived from these two. So the derived ones we will be removing. So we'll be remaining with just two, D tends to A and B tends to D. That is the minimal cover in E. Okay. So this is what the algorithm is about. We just have to apply the rules one by one and see if we can find the minimum dependencies. Okay. Let's discuss about the properties of relational decompositions. Okay. So each attribute in R will appear at least once in the relation, so that no attribute is lost, and we have to preserve the dependencies. because each dependency in the f represents a constraint on database. Okay, so no dependency should be lost. Okay, and there should be no generation of spurious tuples, because that is actually not existing tuples, that should not come in the result. And if there are any possibility of anomalies, we will be separating the attributes into two tables. Okay, so here's an algorithm for finding the minimal cover of f of the set of functional dependencies on E. Okay, so here first we will be considering the functional dependencies f is equal to E. Then we will have here x as a1 a2 till an. We will be separating it. What do I mean is x tends to a, x tends to a2 to a3 till an. I will have separate things here. For each of these things I will have b also. So I will have this formula here, replaced x tends to a by x tends to b, and after that we will be writing for f. Okay, so how does this algorithm work is we will be considering one example. Okay, so before discussing the numerical, we will have to know what is dangling tuples. Because of null values, some of the attributes will have no values in the one table while they have values in another table. Okay, so this will cause some confusion. That is known as dangling tuples. Okay, so here are some of the important questions and the previous questions. So the questions you can expect in exam are of these types, like given the set of FDs, and you'll have some FDs here, and find the minimal cover of G. Okay, so you have to find out the if this is the minimal one or not. Okay, so how can you find out is, first what you do, you write here it is given, right, A tends to B C D E. Okay, so separate it. A tends to B, A tends to C, A tends to D, A tends to E. Okay, and CD tends to E, right, like that only. If RHS has some other multi-valued attribute, you have to separate it. Okay, after writing this one, what you have to do, see here, CD tends to E. Okay, so anyway you can get CD from the remaining ones. If anyway it's possible, you have to check that one. Okay, so what you can do is, you can combine these two. See, A tends to C, A tends to D. You can combine these two, right? A tends to CD. We have studied in the inference rules, right? If you have x tends to y, x tends to z, we can write x tends to yz. So I can write here A tends to CD. Then what I'll have, CD tends to E, right? So I can remove this CD from here, and I will be remaining with A tends to E. That I already have here. So what I can do, I can remove this one, because that is already derived from these two and this one, so I need not have this one. So when I remove this one, I will have in remaining this one, these three and this one. So this is redundant data that I will be removing. After removing this one, what I will be remaining with is A tends to B C D, A tends to B C D, and C D tends to E. These two are the final things which we need. We can't simplify it further. So finally we'll get the minimal cover of G as A tends to B C D and C D tends to E. Okay, the second question is the similar to the first one which we discussed. So here what we have is f is equal to A tends to C, AC tends to D, E tends to ADF. So what will be our first step? Our first step is to separate the RHS. Here in RHS you have three parts, A, D and F. So if you separate it, you will have E tends to A, E tends to D, E tends to F. The next step is to separate the LHS part. In LHS we have AC tends to D, so we can write it as A tends to D and C tends to D. That's what we will write in the second step. Okay, so when we have written all of these, one thing we can observe, if we consider A tends to C and multiply A in both sides. Okay, if you multiply A in both sides, what we have, A tends to AC, or we can write A tends to AC. When we have A tends to AC and AC tends to D, in the question only it's given AC tends to D. Fine. When we have both of these by using the transitive function, what we can write is A tends to D. Okay, A tends to D is the thing which we get. So we will check if it's present in the previous values or not. It is not present, so we can replace this one by A tends to D. Okay, that's all what we have to make the difference, and we cannot find any more simplifications. So the final answer of the minimal cover will be this much. Okay, also one thing you can observe here, that E tends to A and A tends to D. So what you can write, E tends to D. Directly you can write, right? So we need not have this separately, right? So we can eliminate that one. When we eliminate that one, we'll have these states left here, these two states and this one and this one. So combine these both, A tends to CD. Combine this one and this one, E tends to AF. So these are two final answers which we have here. Okay. Suppose that we get a question of this type in exam. We have a relation with five values here, A, B, C, D, E, and the functional dependencies are given as CE tends to D, and D tends to B, and C tends to A. Find all the candidate keys. What is candidate key? Before that, what is a primary key? Candidate key and primary key are like if you have roll number here and we have SSN here. These two are the candidate keys. Both can be chosen for identifying unique tuples. So if I choose this one as the primary key, this will be secondary key. But anyway, both will be candidate keys. They will be used to identify the unique tuples. Okay. So by using these two or any of these, I should be able to fetch all of these values. Okay. So that is the primary key. Now we have to find out which all the keys are candidate keys. If you observe here carefully, in the LHS part, CE is determining D. Okay. So C is a possible there is a possibility that C can be candidate key because it is determining D. Okay. B cannot be candidate key because it is nowhere appearing on the LHS part. Okay. And what about E? E is appearing here. What about D? D is also appearing, but it is appearing also on the RHS. So D cannot become a candidate key because some other key is already using it to identify D. Okay. So we cannot use D in the LHS part. Okay. What about A? A also cannot be the candidate key. Why? Because A is nowhere appearing on the LHS part. So one thing only you have to observe, whenever we want candidate key, what we need is that key which determines the other keys. Okay, and it does not appear on the RHS part. So which are those keys? C and E. Okay. So we found out our answer. Which is C and E. But how can we prove it? One thing we can do. CE determines D. So D is done. D can be found out. What about B? D tends to B, so I can replace this with B also. So C determines B. B is also done. Also C will determine C itself. C will determine E also. E will determine E itself. Okay. So E and C is also done. Okay. And finally we have A. So that is given in the question only. C tends to A, which is C is determining A. So by using C and E, I can determine all of these rows, all of these column values. So therefore, I can determine all of the tuples. So therefore, what I can conclude is C is the candidate key. Okay. So how I will write that is, firstly, you will have to see which are the attributes presenting only on the LHS part, C and E. So we'll check if C alone can determine all the values. C cannot alone do that because we need E also, right? Because C, E both determine D. If only C is there, we'll just have A here. No other can be determined. Okay. So E also cannot alone determine every other attribute because E tends to E only. So therefore, C and E together form the candidate key. By using C and E together, we can fetch all the values A, B, C, D, and E. Okay. Hence, C is the only candidate key for the given relation. Okay. The next question is that let R is equal to ABCR relation and F is equal to A tends to B and B tends to C, a set of dependencies for this relation. The question is, find out the candidate key in R. Is R in BCNF? Justify your answer. Find the possible violations for BCNF for R. If R is not in BCNF, give a decomposition of R in relations that will be in BCNF. Let's solve the first question. Find out the candidate key in R. What is a candidate key? The key that is used to determine all the other tuples. So if you observe here, in RHS which all keys are there? In LHS which all keys are there? A is there and B is there. But we cannot consider B. Why? Because B is already appearing in the RHS. So eliminate B, will be remaining with A. A is used to, A can be used to get A can be used to get B because it is given here. Also A can be used to get C also. Why? A tends to B, B tends to C. Therefore, I can directly write A tends to C also. So A can be used to fetch A, B and C. Therefore, A is the only candidate key. Okay. And is R in BCNF? BCNF should not have any transitive relation. Is there any transitive relation here? Yes. A tends to B, B tends to C. So that's a transitive relation, and therefore it is not in BCNF. Okay, means R is not in BCNF. The possible violation, that is simple. A tends to C, which is the transitive relation. If R is not in BCNF, give a decomposition of R in relation that will be in BCNF. To give a to make a table which is not in BCNF to a table which is in BCNF, we have to separate it, so that it will not have transitive relation. If we separate this, we will have two tables, A tends to B and B tends to C. Okay, so that's what the answer is. We have two tables, R1 and R2. So in this decomposition, there will be no transitive relation, it will be in BCNF. Okay. Moving on to the fifth question, the question is that consider the following relation for published books, and book relation is given where the primary key is book title, author name, book type and list price, author affiliation and publisher, and the following dependencies exist. Book type and publisher is dependent on book title, list price is dependent on book type, author affiliation is dependent on author name. So we have three dependencies here. Okay, so if you make the schema diagram, it will be like this. So a book type and publisher, it's dependent on which one? Book title. The second one, which is a list price, it's dependent on book type, and third one, author affiliation, is dependent on author name. So if is it in 1NF or not? 1NF means multi-valued attribute should not be there. So none of these attributes are multi-valued. Therefore, it is in 1NF. Second NF means what? It should be whichever is non-prime. These are the non-prime attributes. They should be totally dependent on prime attributes. Means both of these. Means suppose if I take book type, okay, book type should have like this with author also and book title also. But it is not the case, and it is true for all of these. None of these are totally dependent. So what we have to do? We have to make it separate tables. How many tables we will make? Book title is for publisher and book type, so we'll take that as separate one. Author name is for author, we'll take it second as a separate one, and the third is the only primary keys here. So we'll have three tables with only primary keys, and this is the primary key and the dependencies here, and this is the primary key and the dependencies here. That is now these tables are in 2NF. The next one is 3NF. What does 3NF say is there should be no transitive relation. As you can observe here, this is the SSN, this is the primary key. It is dependent on book type, and book type is dependent on list price. So therefore it is transitive relation. We'll separate into two parts. First is this much and second is this much. Okay. So if we do in 3NF, we will get here book title with a book type separate, and book type and list price separate. Okay, so it is in 3NF now. So after reaching 3NF, that's the max where we can reach for the third form of normalization. Fourth and fifth do not apply here. Okay, so this is the final answer. The next one is the car sale database. Okay, here we'll have one table which is car sale, and the primary keys are car and salesman. Okay, the rest of the keys include date sold, commission and discount. Okay, and assume that a car can be sold by multiple salesmen. So therefore both of these will form the primary key. One of them cannot form, like car cannot be form a single primary key. Why? Because car will be same car will be sold by different salesmen, so it cannot be used to find out unique values. So when we do this combination, that will be unique value. Okay, so here are some dependencies given: car with a date sold, car with discount amount, date sold with a discount amount, and salesman with commission. If you make the schema diagram here, we'll be easily able to understand where we have to make the changes. Okay, it is in 1NF because it's single attributes values, and it is not in 2NF because there is partial dependencies, right? What does partial dependency mean? The non attributes will have dependencies on one of the attributes here. See, date sold should have the dependency both on car and salesman, but it is only with car. Same goes for this one, only with car, and here also it's same, only with salesman, right? So we have to make these changes. How can we make? By separating the tables. When you separate the tables, the date sold and discount amount is dependent on car, so a separate table here. Second one, car and salesman for all the primary values here, and the third one for salesman only. Okay, so this is in 2NF now. Is it in 3NF? No, it is not in 3NF. Why? Because there is a relation here which is date sold to discount amount, and date sold is from car. So here is a transitive relation. So you have to overcome this one. What we will do? We will make two separate tables where we will have first car to date sold and date sold to discount amount. Now this is in 3NF. Okay, that's the final answer. Most of the type of the questions which are in the previous papers I have already discussed in these 6 questions which I had taken now. So you can go through this one and you can find out what is the similarity and solve this one also. Okay, so that's all for this video, and thank you for watching. I'll see you in the next one.